Hi, welcome back. So we're in chapter 3, what you must know. In this chapter, I have picked a number of topics that I do believe in order to master the use of the mathematic language, you need really to be much more familiar than ever with each one of those topics. First, we're going to start the number system. Then we're going to be looking to the universe of polynomial, and then equation function system, trigonometry from the geometry perspective, also the irrational number and its natural logarithm, exponential function and logarithm, also derivative and integrals, matrix with the property of eigenvalue and eigenvectors, finally combination and permutation. Let's go ahead and start with the number property. Only we have seen the definition of number system and how many different category of numbers that we sum up together sit inside another set. Now, regardless of the type of category of number system, there are certain properties that each number category actually sustain: the addition operation and the multiplication operation. So the first property, talking about commutative property, and it says if you take first term and add it to the second, is exactly equal as if taking the second term added to the first. So a plus b is exactly the same value as b plus a. The same thing with multiplication. If you multiply a by b, it's the exact same result as multiplying b by a. The second property about associative property, which says that taking the addition of two terms like a plus b and then the sum or the product of that added to a third term c, it's exactly equal to a plus b plus c. The same thing for multiplication. A by b, the product of this multiplied by c is equal to the product b by c then multiplied by a. The third one about the identity property. Now, identity with addition related to 0. Same for multiplication, but the product here is 1. The last one is the distributive property, which says that addition of two numbers like b plus c, multiply that by a scalar like a, it's exactly equal. The scalar a multiplied by each number, sum them together, you will get the result identical. These are 4 important properties of number. Next thing we want to talk about actually is an important subject related to the universe of polynomial, image of polynomial from visual perspective. So basically, what is polynomial? Polynomial starts from the idea of having poly and nominal. It means many terms. So the idea is we have terms. I'm going to write here expression to define those terms. So if I would have term 1 here and another term and a number of terms, separate those terms, we could look at number of operations. A number on its own, it's a term. A letter is a term. If I would have to talk about the power or the exponent, this is a polynomial. Again, we say with power of 2, y and z. These are also a polynomial. In this case, y is power 1, z is power 1. The power of this term, it is 2 because I have to sum the two powers. There are 2 important conditions and not apply to a polynomial. If we have power negative, it means this isn't a polynomial. The second condition that I can't have a term, the letter, as a fraction. For example, this, it isn't a polynomial because variable is considered to be a fraction. So let's see the general, most basic form of a polynomial. Let me give you an example here. Quantity of something and price. Now, let's assume that I have certain items, right? Item X and item Y and item Z. So any number in R could be a price for something. I'm going to choose 3 of these X's. I choose 2 of these Y's. 1 of these Z, a price of 10. In some books, you might see the presentation 3 of these X, 2 of these Y, 1 of these Z. 1, it's the indeterminate variable. And Z actually is the coefficient. Now, many people might be surprised when I make such a presentation, but let's think about it from a logical perspective. What does indeterminate or variable actually mean? It means it could be a value of anything. Right. Now, here in my example, I have item X, I have item Y, and I have item Z. This 3 it is X. This 2, it is Y. This 1, it is Z. It will represent actually, eventually, the independent variable. The actual fact that 3 is the meaning of X itself. So instead of writing 3, I could have written this as an X. Now the books or the confusion happens here. These terms or the letter I am using, X and Y, and Z, conceptually understood, they are the same as this X and Y and Z. They aren't the same actually. So instead of writing this, I'm going to just say the value of all of these map to another number 10. I call it the p-value or the price of that. I need p to be presented here. I could have p1 and p2 and p3. In the book, it's better to see them as alphas, as I've written them there. Now, this is a coefficient. So what is the coefficient and the meaning of coefficient? Coefficient represent these little values which are actually on behalf of the right-hand side of the equation or on the exact form of this term. The question is, what is the value of these coefficients? These alphas, I mean what I have written here, is the entire foundation of artificial intelligence. Let me share with you one more example. You have this prism rectangle, and I am interested actually to calculate the area of this rectangle. Now, if I was to unfold this rectangular, it would look like something like this, that each piece of them, it represents a rectangle. So in R2, that the width multiply by the height of that rectangular, that would lead me to the area of this. I would call this is my X, which is represent the width. This is my height, and this is my depth. So I would call the depth as Y, and I would call this as Z. Down here, which represent this, the front. I know that X should be multiplied by Z to lead me to the area. Now, if I want to take another side, like say, for example, this right side, this is my Y multiplied by my Z. And then finally, bottom, it will be just X multiplied by the Y. Essentially, this presentation, it looks exactly like this. Bottom, the front, and the side. This is an area, and this is an area, and this is an area. So this area actually, it's the sum of A1 plus A2 plus A3 anyway. Again, related to a quantity as the previous example. And what do I mean with the quantity once again? How many pieces I took. So you could see here, I have like the right and the left. Because they are identical in shape and size, I will call them, this is a quantity 1. And the backside, they are equal. I would call them quantity 2. And then you have the bottom and the top. Again, it's a quantity 3. So basically, I could have one quantity here and another quantity here and another quantity here, which all of them lead me to the total area anyway. So the question is how to rewrite this. It would look like this. It's a Q1 alpha 1 plus a Q2 alpha 2 plus Q3 alpha 3, which is equal to the area. Q1, Q2, it's the indeterminate variable. Could have been any value. And this is my coefficient. This coefficient, a product of two different values, which happens to be a value 1 multiplied by a value 2. It doesn't really matter. It could have been a singular number like the previous example. I just use the concept of polynomial of understanding to create or to perform this particular image. This Q, which is going to be actually the actual form, this going to just replied by 2 and 2 and 2. Actually 2 here is the indeterminate variable. Could have been only 1. I calculated only one side. But if it could have been a 3, it could have been 1, depends on the design of the prism. But the point is, this is indeterminate variable, could have been any, but these are the coefficient, and they are actually the representative of the domain of the area. So that was all for now. Next, we'll be looking at equation and function and system. I will see you then.